the last half of 13.1, and we're also going to start the law of sines, which is 13.5. We're going to kind of put those two together because there's not a lot of material here today. So angles of elevation and angles of depression. If you guys recall, your angle of elevation is how far you are off of your horizontal looking up. So if you imagine you have an imaginary horizontal line as your line of sight, if you will, the angle then at which I'm looking up is measured from the horizontal to that object. So in this case, it's the person looking up at the kite. Now, that rise, if you will, is the exact same angle as it would be as what we call the angle of depression. The angle of depression is the view of the angle looking downward. Yes, ma'am.
Are they?
They are, and I was just going to say that because these two are imaginary horizontal lines. So when you have horizontal lines cut by a transversal, their alternate interior angles are congruent. This is where this all comes from. So depending upon what they're saying to you in the style of the problem, sometimes they might give you an angle of depression. Remember that the angle of depression is the exact same thing as the angle of elevation. Okay? These are extremely easy style problems. It's just a matter of being able to draw a diagram and go with it. So, let me show you an example. I just have to read this one. Sorry about the cut through there. I'll just have to read it to you. I should have ran this off, but I didn't ran out of time. An airplane takes off 200 yards in front of a 60-foot tall building. Sounds smart. At what angle of elevation must the plane take off in order to avoid crashing into the building?
Not putting an air.
Not putting an airstrip in front of a building is usually a good idea, but just in case, let's take a look at what this would look like.
Truck. I like a barrage balloon.
Camel.
Yes, that's your.
Wait, why is that called camel?
I don't know.
Camel plane.
So here's your airplane.
Huh?
I'll put them on the other side because it's easier for you to do.
Hey. That's sweet. That's good.
That's good. So the airplane is on a runway, and that runway is 200 yards from a 60-foot tall building.
Nice. Yeah, I heard it.
Good. That's what you should. Now here's the thing. A lot of these types of problems will switch between units just to annoy you. My recommendation is to always convert to the smaller of the units. By doing that, you will alleviate the having to worry about a fraction or a decimal equivalent. There's only a few conversions that I'm going to hold you guys accountable for knowing. It's kind of like the normal ones, as in there's 12 inches in a foot,
Wait, really?
3 feet in a yard, and 5,280 feet in 1 mile. Good.
Wait, what is it?
Because you're an American.
Wait, 5,280.
And any red-blooded American needs to know that. America. So, in this case here, see how I have 60 feet and 200 yards? Which is the smaller unit?
Feet.
Oh. So, what do you have to multiply 200 by to turn it into feet? 3. So what's 200 times 3?
6.
So this is 600 feet. Now our units are okay. Now they're asking us what would the angle of elevation have to be in order for this airplane not to crash into the building, which means you need to find theta. Think about SOHCAHTOA in this case now.
Oh, you do
60.
No, you're not trying to find the hypotenuse. You're trying to find the angle.
Can you assume that 90 degrees?
Yes, and that's a good point here. When they're talking about these problems here, last time I checked, we're not running into the Leaning Tower of Pisa, so most buildings are square to the ground. Otherwise, they fall over.
Besides the Leaning Tower.
Beside the Leaning Tower of Pisa. So, oh!
Let's go.
You're not gonna make it. All right. What trig function are you gonna use?
You know you're gonna take all day to do this.
Yep, exactly right. So we're gonna use the tangent of theta is 60 over 600. And what do you have to press in your calculator in order to find the angle? The inverse tangent, which you guys probably learned last year, is called arctan. I don't know if you guys knew that. So it's not the inverse of tangent, whereas we're talking about cotangent here. We're actually just pressing the second button on the calculator to find the angle.
I thought the inverse of tangent was the thing
Okay.
we learned.
It is. The inverse function, what we're doing is we're undoing it. So in your calculator, you basically type in that, the tangent to the -1. And that'll allow you to find your angle. Now, could you have simplified that fraction?
Yes.
Do you need to?
No.
No, your calculator does it.
5.71.
You put it in exactly like this. And once again, guys, write down what you're about to type in the calculator prior to doing it, so that way we have half a clue. So what's the degree?
5.71.
There you go.
Wait, how do you get 5.71? I keep getting 0.5729.
Then you're not in degree mode. Press the button that says mode, and make sure you're in degrees.
I am.
Then you're doing it wrong.
No, I'm not.
Are you sure?
Yeah.
You want to bet? Well, I said you didn't need to simplify the fraction, and you did try to simplify it, and you did it wrong. So hence, you did it wrong. You don't have to. It's okay. You don't have to simplify it. The calculator will do it for you. Okay? Yes, sir.
I think I'm doing it wrong. But
Well, that was what I'm saying.
Well, I'm really stupid.
You're not stupid. You just made a stupid mistake.
is my counter like?
Press the button that says mode. You're in degrees. Okay. And this is in.
Mine is.
There you go. So, like I said, not that difficult, is it?
No.
All right. Let's try a different one.
Yes.
There we go.
Luke is 6 feet
Oh,
tall.
wait.
All right, we'll do the loop one. That was fun.
Sweet, what? 30 feet from the ground.
Yes, the penthouse is 30 feet from the ground. So this is some pretty awesome buildings here. So Luke is 6 feet tall. He's squirting a squirt gun through Alex's penthouse window suite, which is 30 feet from the ground. So Luke has got a super soaker. And he's standing at a horizontal distance of 50 feet away. Now, a horizontal distance, is that left and right or up and down?
Left and right.
Okay, so we know good old Luke.
Oh, nice.
I see it.
You can draw his work on that.
Wait, hold on, he's got to have his arms have to be up a little bit
You have
higher.
to draw the gun.
Yeah, I don't think that works.
Well, his nose connects.
Oh, that was kind of.
Wait, it has to be
It's just
squirted.
like one of those little squirt guns.
It has to be squirted. Yeah.
He's got like a grenade launcher squirt gun.
Okay.
Okay.
You're
He-
gonna fire you.
Yeah, I gotta be careful here. There's an imaginary water
I
gun.
just tweeted that.
So the house is 30 feet. How high up is the gun if he's shooting it up 6 feet up?
How about 5?
This is kind of like a dumb idea here. We'll just say he's shooting it from 6 feet up off the
So is he
ground.
like doing this?
Yes.
What?
Oh, like that.
And he's actually turning it sideways because it's cooler when you shoot a gun sideways.
Kill shot, yeah.
Now, here's the idea. We know that the horizontal distance is 50 feet. You can still assume it's making the right angle there. If the building is 30 feet, but yet he's shooting it from 6 feet off the ground,
It's just 20
exactly.
feet.
So your opposite height then is 24. What I'm trying to show you here, guys, is that sometimes you have to do a little conversion where you're building it into a diagram that you're just offsetting your heights. It happens quite often in these style problems. It's not a very difficult thing to look at. It's really, really simple. No, this is not to scale. Luke is really probably not 18 feet tall.
It looks like Luke on my paper is like 20 feet tall.
Oh.
Maybe taller.
What trig function are you using here? Tangent again. But I want to make sure you guys realize you're not always using tangent, so this is pretty easy. Let me show you one that you don't have to use tangent.
It's fine. The elevation 290
It's 25.
Yeah, the elevation percent is 6.7
I'm trying to remember which one it was. Oh, look at the golf one. Look at the golf one.
There's actually a picture that goes.
This one has a picture, so you don't have to try to sketch one out. Even though drawing, I love doing these types of problems because the pictures can be so absolutely absurd. That's what's just fun about it. So a golfer standing in the tee, he's looking up to the green on a hill. If the tee is 36 yards lower than the green, and the angle of elevation to the hole is 12 degrees, because everybody knows all that kind of information on the scorecard.
Yeah.
The GPS says it in the cart in certain places. It's normal. Find the distance from the tee to the hole. So you've got a horizontal distance, you've got a vertical distance, or a diagonal distance. Which one of these are you trying to solve for?
Horizontal.
Sine.
The hypotenuse, the diagonal. Think about it. If your tee box is here and the green is here, are you going to hit the ball underground? Oh! No, you go this way.
No, I didn't.
I usually do that.
I
I
see
don't know about you guys.
You
Right
stole
underground. Goes right underground and then comes up right in the hole. Pulling one every time.
Don't you do that in mini golf?
Yeah, mini golf.
So in this example, what trig function are you going to use? Sine. Good. Now, just remember, every once in a while you're going to get a different value. So sine of 12 is 36 over x. What do you do when your variable is in the denominator? Do you remember? Just flip-flop them around. What was that? I'm sorry? I didn't hear you. What do you guys get for that then? How much?
170.
So 173 yard, the par 3, what is that for you? It's probably about, what, an 8 iron? 173? 8 iron for you, I bet? It's a full 7 on me. And I've got a wingspan that's like 2 feet more than yours.
8.
Jerk.
I got 173.
We were talking golf stuff. Don't worry, Phoebe. 173 point something?
173.1504364.
Remember, when you're doing these types of problems, guys, keep it to 2 decimal places will be all right. Okay?
Hey, I was just trying to get it exactly right so I know what club to use. Like if it was 173.1505, I'd use that.
Now, do you have a rangefinder where you actually a sight finder?
Yeah, and it like calculates slope too.
That's exactly all this is.
Yeah.
Those rangefinders, that's what these things do. They're doing the trigonometry of it, all built into the sites. You guys remember Ben Setchel?
Yeah.
You guys know he's a big archer, archery guy.
Yeah.
He's sponsored by people that give him like really, really expensive stuff to use when he's out hunting and doing stuff. When we did, you guys know how you did your angle of elevation project last year and something. But we were in the auditorium.
Yeah.
He brought his in like 3 years ago or 4 years ago when he was in my class, and he was citing the things out and checking our work and how close we were in our with what we were doing. We were really, really close, and that thing was a laser sight. So it was pretty cool that what we were doing, just that little paper clip and the compass, it was working. It did the same thing. So next time you're on the course, just bring a paper clip and your calculator. Every other
This might
location.
take a while.
Yeah, the guy you're playing with is going, nerd. We okay, elevation, depression? All right, let's look at law of sines then.
Law of sine.
Law of
Wait,
sine.
is that
Law
like-
of sine.
Wait, is this the same?
We're jumping into 2 things today. We're going to talk about law of sines as well.
How'd you do that?
He just knows.
Yeah, it's like the law of the West.
Yeah.
Law of sines.
It's witchcraft.
Kind of scary.
She's like lost.
No, how do you make this out?
You tapped it.
He taps it. It's magic.
I get it.
So, Wow. You guys okay?
Yeah.
Wow, he's here for math. Anyway, law of sines. Law of sines, if you guys recall, is for solving triangles that are not right triangles. Okay? When you're using the law of sines, it's basically, it's the sine of one angle to the side opposite is to the side of, or sine of one angle to the side opposite all the way around. It's just a matter of lining them up. Today, what I'm going to give you guys with the examples of law of sines are going to be ones that will work no matter what. Tomorrow, on the other hand, we're going to get into what happens when you have the angle side case.
Hey, you can't do that.
Yes, you can.
Oh.
So the sine of angle A is to the side opposite, as the sine of angle B is to the side opposite it, is to the sine of angle C to the side opposite that. Now, what I want you guys to notice here is that you've got three ratios. You only need two of them to set equal to each other. And it could be A and B, it could be A and C, B and C, it doesn't really matter. It also doesn't matter if you rewrote them with the side length over sine, because of the reciprocal properties of ratios, it works. It just, don't do it. Okay. If I recall from when, just from the regular, my guys in geometry last year, this was really easy. It's just a matter of writing it out and setting it up. Okay. The trickiest part here is when you're pressing buttons in your calculator, is to make sure you close parentheses. So let's look at an example.
True.
Don't worry about the case here with this angle side and the angle side angle here. I'll explain that more in depth tomorrow. So if I want to solve triangle ABC that has angle C of 103, angle B at 28, and side B at 26, what do you think the very first thing I want to do is?
Draw it out.
Draw it out.
Okay.
I want to draw it out just to get an idea of what it looks like so I know what goes where. Does it need to be drawn to scale?
Yes.
No.
I need a 26-foot paper. At least.
Okay. Now, one of the things that I usually do when I'm working with the law of sines is that as soon as I see that I have an angle and it's side opposite, I circle them because that's what I'm going to use as my pivot. I'm going to use that value to find everything else within the triangle. So here, you'll notice you've got both of these guys.
All right.
You okay with that?
Yeah.
So I'm going to write that out, that I know that the sine of 28 is to 26 as, well, the other angle that I'm given is the 103. Sine of 103 is to C. We okay on that?
Yeah.
All right. Fraction equal fraction. All you have to do is cross multiply. Now, let me show you how this is going to wind up working. I'm probably only going to have to walk through it once, and you'll probably start to pick up on some shortcuts, and that's perfectly fine. When I cross multiply out, I get 26 sine of 103 is C times the sine of 28. Are we okay on that? Notice I'm putting the side lengths prior to the sine value. By doing that, it's going to help alleviate some of the issues with parentheses with your calculators, and it kind of forces you to remember to close parentheses and all that kind of stuff as well. Now, to get C by itself, all you have to do is divide by the sine of 28. Now, remember, the sine of 28 is just some crummy decimal. So in my calculator, I can type it in as, let's see, yeah, exactly. There we go. Alpha y equals fraction, what was it, 26? 26 sine 103 over 5396?
Yeah.
So now my side C is 5396 because it's two decimal places.
Then we have to find A.
Yep. Finding, what are you going to find first, angle A or side A?
Angle.
Angle A.
49.
You can just subtract those numbers.
So what do you get for angle A?
49.
So now reuse that original
The original.
sine of 28 and that side length, because that's what you were given.
Yeah.
Because even if you, because let's say you screwed up this, if you reuse this, is this ever going to be right?
No.
No, go back and reuse your givens. Every time you can reuse a given, you're going to be better off. So we have the sine, 28 is to 26, as the sine of 49 is to little a. All right. You might start to realize that it's one of those where you can try to shortcut it after a couple of times, because you're going to cross multiply and divide. You might even recognize it right away that you wind up with, let's see, 26 sine of 49 over the sine of 28. Take your side way of the bay. 4180? Okay.
We'll see.
Now, what's one thing you guys can do when you're looking at that triangle then to kind of get an idea if it makes sense?
Add all the angles.
Well, that'd be helpful, yes. Well, what about with side lengths?
Make sure
Oh,
you
the
add them
smallest
together.
one would be across from the
Yeah,
smallest angle.
just to get a quick idea, if the smallest side is across from the smallest angle, you're probably on the right track. Okay? Because if you remember that from geometry last year, that the side lengths and angle measures kind of correspond with one another about largest side, largest angle, and so on. Okay? Good.
All right.
One more.
Yeah.
Wait, are you really gonna do?
Yeah, I want to do that because I don't want to go into this yet because that's too soon. I want you guys to do these first. Yeah, let's do this. Let me give you some problems here. And it's going to be over 13.1 and 13.5.
Oh, yeah, just Oh, dude, I didn't do that thing for her
Because I kind of
video.
want to get it over with.
Right now?
Yeah, I didn't.
How would you like so? You're so bad,
Hey, Joe.
Joe, by the way, I was in the university and I borrowed your and no, I did not find it.
There you go. Do those two sets for you real quick. It shouldn't be that bad.
I figured I needed to tell you.
Most of the problems that you have for the angles of elevation and stuff, they kind of already give you a diagram, so it should be pretty easy to work yourselves through it. All right? Questions?
You have Alexander, right?
Like I didn't even hear the song. I just thought of it.
She wrote some raps. They're pretty good.
She's something, all right.